Okay, now let's go. All right, last time we were talking about ToString. That's where we finished. In Python, we used underscore underscore repr, which was this way we would signify or tell Python, like, okay, if anyone wants to see a string representation of this object for this class, this is what will get called. So if I ever come along and say, print the name of my object, we'll see this repr is automatically called. In Java, there's the same idea, except instead of underscore underscore repr, it's ToString. The ToString method, the point of it is to return a string that represents this object. And it automatically does get called, like in Python. If I said like system out print a friend, where a friend is an instance of a friend object, and I'll show you this in a moment, an example of this, it'll automatically call the ToString. So we could explicitly call it, but we don't have to if we are printing it out. So here is the friend. So I got all these getters and setters. I'm just going to copy this. I'm going to have to deal with the annoying... Whatever. Paste. Okay, there we go. So all I want to do for my ToString is print out, or pardon me, is return a string that is the first name with a space, last name, then a colon, tab, email address. That's it. That's the string version. And you might be saying, well, why not include the birth year? Fine, I could do that. Why did you do it that way? And why not did you have like why didn't you do like last name, comma, first name? Because it's a ToString. I can do whatever I want here. So I'm going to save this. And now if I have my friend and I do this, I can write, we'll give it a second. There we go. John Doe, jdoe@gmail.com. This automatically calls the ToString. In the same way in Python, it would automatically call the repr. I could say ToString if I really wanted here, but it's not going to make any difference in terms of functionality because Java doesn't care. You don't need to say the ToString. So there we go. Pretty neat. So there's the ToString. We like to write ToStrings because when we have an object, sometimes it's nice to know, like, okay, let's say you're writing your code and you're doing some debugging. You're like, is this object the one I think it is? Let me print it out and see if I get what I expect. You know, that's great. Seeing this, John Doe at jdoe@gmail.com is a heck of a lot better. If I get rid of this, I get the default ToString. And I run that and I see friend at 65AB7765. What does that mean? That doesn't mean a lot to me, does it? I'm going to run it again. Let's see if we get a different number. 7765 is the last. Oh, it's the same. So this isn't very helpful for me. Where this, I override the one that we got for free. In fact, you'll even see this little symbol here that's saying, this overrides. You overrode it. You overrode a method from another class. So anyways, and this right here, I clicked that. And so this is actually the object class. Everything in Java is a descendant of an object class. More on what descendant means way later in the course. But because of that, this ToString is what we get for free. This is the one we got for free. If I didn't write the ToString here, I would get this one for free. And what it does is it says, get the name of the class, get the ampersand, and then toHexString is hash code this object. We don't need to talk about what that means at any point in this course, really. Well, we could talk about that way later maybe, but it's not important for right now. But the point is, this is the one we got for free. This is the code that gets run. I could take this, paste it here. So I overrode the ToString with the exact same code, and we'll see that friend at blah, 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 blah. I could change it to plus this blows. What's it mad about now? Oh, there. Okay, now let's run. Friend at this blows. Great. But of course, that's not all that great. This is far more helpful. Warning. This is a big one. It returns a string. It doesn't print anything out. This is a very common mistake. This is a mistake I make. But it returns a string. It doesn't print it. See? Returns something of type string. Here, I'm printing out what I got from the friend, but the method itself returns the string. So, are we okay with that? Any questions? Okay, so is it recommended to create instances of a class in the main method? Yeah, you could totally do that like we did here. Oop, right here. Yeah, we could do it here, but we'll see examples of us making instances of classes or instances of objects in other parts of the code very, very shortly. What's up? Is that a... All right. All right, equals. Great. So we also saw another example of a fancy method in Python, __eq__. And that was a way to ask if two of these objects are equal. For free, if I give you the integer 7 and the integer 8 and I ask you if they're equal, I don't need to describe to you what that question is. Like, well, what does it mean for these things to be equal? Because you've been doing that since you were this big, right? Like, you know about integers. But when I have like a friend object and another friend object, what does it mean for two friend objects to be equivalent? So that's kind of a different question, right? Because like, well, I don't know. You tell me. So that's what this was for. And in Java, we have the same idea, except instead of calling it ___eq__, we call it equals. And it's a method to define what it means for two objects to be equivalent. But unlike Python, this doesn't overload the equals. You might remember in Python, if I had let's say I did this. And I said, my other friend. In Python, I can do like my friend equals my other friend, right? Like that's a valid question. Here it's going to say it's not a statement because I haven't done anything with it. Bool A, there. Now, no, Boolean, there we go. Boolean A equals that, right? But in Python, if you did this, this would automatically go and call the __eq. In Python, it doesn't. In Python, we would need to say my friend dot equals my other friend to check if they are equivalent. Now, I'm going to show you an example of an equals that's really not the correct way to write the equals in Java, but we will discuss the correct way a little later. I'm just going to show you an example of getting it working, however. All right, so equals the default behavior to check if the, okay, this is important. If I don't write my equals, so there's no dot equals here. If I say my friend equals my other friend, they have all the same values, right? John, Doe, J-Doe at Gmail, both born in 1999. They're the same, right? Well, let's see what happens when I run this. False. And you're looking at this going, but they're the same. Well, the problem is twofold. One, we never actually define what it means for things to be equal. And equals on objects doesn't tell you if they are equivalent. It tells you if they are literally the same object in RAM. So if I do something like this, my other friend equals my friend. There. You might remember I just created an alias for this object. So I have two variables called my friend and my other friend that reference the same friend object here. If I do this, my other friend, now it will say true because they are literally the same object. I just had two things pointing to the same friend object in memory. So I wanted to find what it means for two friends to be equivalent. Well, we get to make it up, right? We are defining this. Remember, we are God in our world of the program we are writing. So what does it mean for two friend objects to be equivalent? Well, it's same eye color, same height and weight, same number of skin cells. We could play whatever game we want. A couple years ago, I asked someone that question. They're like, same number of dust particles on the dashboard of their car means they're equivalent. I mean, that's absurd, but you could do it, I guess, but it's absurd. What makes sense in our case? Let's just check if their first and last names are the same. Sure, it's possible that that's not very good. Maybe I should check if their email addresses are the same. That's more likely to be unique, but then again, people could share email addresses. Whatever. For our purposes right now, I'm just going to check if the first and last name are the same. So I am going to write my equals method for the friend. Public equals. Great. So here's public Boolean equals friend. So now the idea here is I will ask an instance of a friend class this. So I want to return something. If this dot first name is equals to O's get first name. So I'm saying, okay, hey, me, this, get your first name and check if it's equivalent to the object that was given to me as a parameter's first name. And of course, I want to ask the same question, this dot last name dot equals O dot get last name. Great. There. What is O? O is just the name of the other friend object. So now I'll just show you an example of this run. So now I can say, we see my friend, my friend and my other friend, they are the same. They have the same first and last name. And we saw a moment ago, if we run this, it's going to say false. But now, if I say, okay, hey, my friend, are you equal to my other friend? Now I'm going to hit run. True, because this runs this method, which checks if this, which when this was called, this would be the my friend object, and O is my other friend. So we're saying, hey, is your first name equal to that one and last name equal to that one? Notice how I did not do this. First name equals O first name. And I'm going to do the same thing down here. Great. Notice that I didn't do this. I didn't say, hey, is your first name equivalent to O's first name with equals? Let's hit run and see what happens. Strings are actually finicky. See, it's saying true, but it's actually not. Because strings are weird in Java. To play it safe, don't do this. Even IntelliJ is saying, string values are compared using equals and not equals. It's basically saying you're trying to compare strings. There. Oh, I don't want that one. I want dot equals. There. And then here, dot equals. Get last name. As an easy way to remember, wait, do I want dot equals or do I want equals equals? Whenever you have an object, use dot equals, whenever. And if you're saying, wait, how do I know what's an object and what's not? Our int, our double, our char, our Boolean, these are primitive types. They are not objects. Everything else is an object. I mean, we could say like float. That's also a primitive type as well. But all of these types are primitive types. If you ever see a type that begins with an uppercase, what does that tell you? Oh yeah, what does the and do? And means and. Okay, hold on. What is the O? Why not just default to equals? Because maybe you do want to check if they are the same exact object in RAM. And then the ampersand do, it's a reference type if it starts with an uppercase. It's an, yeah, it means it's an object. In fact, when you make a string, you don't do string. The proper thing is uppercase S for string, and that's because it's a reference to an object. It's an object. So when in doubt, you probably want dot equals. If you're dealing with like an integer, like just basic numbers and booleans and characters and double, like equals equals, sure, that's what you use. But dot equals every other time. It's a reference type. Like, I didn't understand the other line. And he didn't put, so, yes, I see what you're asking. This, there. It's the same. It's just because it's so long and it went off the screen, you can just make it go on a new line. And there are conventions for like, well, these ampersands should be at the beginning of the new line and not at the end of the old line. You know, in fact, I'm actually curious. Will IntelliJ change that? No, well, whatever. This is just to make it fit. That's all. And yeah, you're right. Yeah, forgot you can do that. Yeah, you can. Now, and that's why also there was no semicolon here, because if I did that, that ends the line. Now, ampersand, ampersand. So I want to be a stickler here because Kalen said ampersand, ampersand is and, but it's not. It's actually slightly different. And we will talk about this later, but just to be a stickler, ampersand, ampersand is a short-circuited and, which means that if this is false, do I even need to ask this question if it's an and? No. They aren't the same. So this and this are different. So if this is false, I do not need to even look at this other side. Because if this is false, then I know the whole statement is false. If I do this, if this is false, it'll still evaluate this. Because, and you might say, well, why would you ever want to do that? Well, imagine this method here, this equals for the string. So now we're in the string class. Imagine this had some fancy side effects that were really important in your program that you had to make sure it ran. That's why. But almost always you're going to want the double ands. Oh, I also want to make note here. This equals method that I've written right here belongs to the friend class because it's written in the friend class and it's being applied to friend objects. But this equals here. Where is that equals? Which class does that equals belong to? This is a quiz. Type it in the chat if you know the answer. String, exactly. Okay, but as of now, it's and. Yeah, okay, what, they aren't the same. So one is like this and two is both. What? What's the difference between and? Sure, yeah, go there. And Kalen, you're right. It's because it's in the string class. Because this first name, well, what is that? Well, oh, it's a string. So if you have a string and you say dot equals on it, well, you're clearly calling that method on an instance of a string. And if you're an IntelliJ and you click Control click, it'll actually go to that code somewhere else. And look, we are now in the string class. We scroll all the way. It's a big class. Scroll all the way to the top. Class string, right? So that's the equals method in the string class. Great. So here's the warning though. This example equals included in the friend Java file is a little more complex, but is a more complete and correct equals. See this aside. So I've included this aside on equals, and I recommend, here's your homework. I recommend you read this. It's very short. But this is the correct way to write an equals with all this extra fancy stuff. And it talks about it a little bit in here. So your homework is go through this aside. But for our purposes, here's our equals. Like one means that if it's one or the other, it will react. However, if it's, you need both to react. So it's, no, I think you're thinking too hard here. Ampersand means if it evaluates half of it and it can conclude what the whole expression is, it doesn't evaluate the other half. If you have a single and, it's guaranteed to run both sides of the expression. All right, warning. Okay, creating an instance of a friend. Okay, we already did that. Friend, Bob Smith, bsmith@gmail.com. Great. Here's an example of actually creating an instance of a friend. This is really simple example where we create it and do nothing with it. So yeah, this is a rather silly example. There's nothing happening here. I created it and then nothing's going on in this main method here. There's a bit going on here. Declare a friend variable, friend, a friend, create an instance of it, new friend. Great. So this is the creation of the variable. We're saying, oh, create a variable called a friend for a friend object. And then make a new friend object. And then when you call this code, if we go back here, when you call this code, it's the constructor. When you say new friend and you give it all those values, it runs the code in this constructor. And just to prove that I'm not crazy, s out, I ran. Now when I go here, if I'm making two friends, and when I call the constructor, it runs all the code in this constructor, what should I see as output? Run, let's see. I ran. Because it called it here, it ran all this code, it finished, it returned, then it went to this line, it called the constructor, it ran all this code, it printed it out, it returned, and then it checked if they're equal. So there, you can actually see that it ran because the code in that method ran. Okay, basically single, you are all thinking too hard about this and. Do not worry about it right now. You're getting stuck at the forest through the trees type thing. You can look this up later. Just use ampersand. Most of the time, almost always, you're going to do ampersand. And iPad, Iran, Iraq, that was a Mad TV skit years ago, probably from before you were born. Okay, okay. A little review on references. Now, when we assign a variable to a reference, assign the variable to a reference to newly created object. The equals bit, that's this part right here. Here's the variable, it's declared, and then we are assigning this value to this variable. This is how we can think of it. A friend tells us how to get to that object. Unlike a primitive type, where if I create a variable called my variable, and I say my variable equals 5, the box in my computer with the label my variable, the contents of it says 5. When it's an object, it doesn't work like that. When it's an object, because I know how many zeros and ones an integer takes up. So if I want to make an integer variable, I can go set aside the appropriate number of zeros and ones, the appropriate number of transistors in my computer to hold on to that information. When it's an object, well, we have strings. How long is the string? How much room does each character take? How many strings are on that? There's a lot that can be going on. So what the computer does is it says, okay, I'm going to go and make an object a friend object over here in RAM. But the problem is it's just floating in RAM somewhere. So my variable called a friend has the information within it that tells me how to get to there. So whenever I say, hey, a friend, it's like, oh, yeah, and I go look this up. That friend that's waving there is not in the box. What's in the box was what tells me how to get to that friend. Okay, sorry for off topic, but can the friend class and constructor have the same number, same name? Wait, can the friend class and constructor have the same? No, they have to be. No, it should be the same name. Class friend, public friend. Make sure you don't have like a return type here. It has to be the same name. If they're not, it's going to say like, ah, there's a problem. Does that, because yeah, otherwise there's something gone a little awry. So I'll carry on, but if the problem persists, like add the follow-up question. All right, so if I write another line of code that says friend B friend equals a new friend Jane Doe, well, this is what happens. A friend would have a first name Bob, yeah, because A friend we go here. B friend has the first name Jane. Oh yeah, okay, that's the green one. They both have first name fields, but the actual values associated are different because the information belonging to the person are different. Oh, this is interesting. Both below is an example of two friend objects being created and being used. We get a friend's first name, use ToString, use the equals method. Okay, so friend, a friend, new friend, B friend, friend. Get friend's first name, a friend, print out a friend, print out B friend, ask if they're equals. We were already just kind of playing around with that. Okay. Well, maybe I'm misunderstanding the question Arthur's asking because the constructor needs to have the same name as this. Unless you're asking if you want to have multiple constructors. Like if I wanted to make another thing called like private int, we've got a problem because it's going to say like, well, it's already defined, but the class name and the constructor have to have the same value. I also may be misunderstanding the question too. Sorry for off topic, but can the friend class and constructor have the same name? Because it says there's a problem with them being same names. Yet my friends don't have this error and do the same thing. So I'm confused. Yeah, so when you say friends, do you mean like peers in the class or friends, your friend objects? That's confusing. Peers, yeah, that's funny. Yeah, that's, check for a typo or something because like the name of the class, the name of the file, the name of the class, and the name of the constructor must match. Here, I don't know. Maybe this will work. There, I just copy and pasted everything. See if you can like copy that into yours and see if that fixes it. Maybe some character went funny. Okay, yeah. Okay, references. We have to be careful about what is actually stored in these variables. This is what I was talking about here. It's it's the information to get to these objects, not the objects themselves. So, we have to be careful what's actually stored in these variables. We are not storing the object in that variable. We store a reference to where the object is in memory. So if we look at this code, friend, a friend, Bob Smith, and then we have B friend is Jane Doe. In the above example, B friend equals A friend copies. This is always the case. It copies. I know you're not here, but say it out loud with me. It copies the contents of the A friend variable and puts the copy in the B friend. So the reference stored in A friend gets copied, not the objects themselves. So this is the result. Because the contents of A friend is the address of Bob. Originally, if I scroll back up here, the contents of B friend was address of Jane. Not Jane, but the information needed to get there. So when I say B friend equals A friend, I copy the contents of A friend, which is the address of Bob, and I put it into B friend, which is now the address of Bob. So both are now references to the same object. But of course, Jane over here is now sad because nothing references her. And if this ever happens in your code, if you have an object that doesn't have a reference to it anymore, something called the garbage collector comes along and cleans up that part of memory. Because if nothing can reference it anymore, you can never get access to it again. Therefore, it can be deleted by the computer to free up space in RAM. This is called garbage collection. In other programming languages, and that's like, we talk about memory in topic 18. So this is just a little tip of the tip of the tip of the iceberg. But in other programming languages like C++, garbage collection doesn't happen for you. And if you did something like this, you would have a memory leak, meaning that your program has allocated itself a chunk of RAM on your computer that never got freed up, meaning that that chunk of RAM is now stuck, which is a problem. It's a memory leak. Okay. You may think that assigning works differently for this is a big one because a lot of people get confused by this because they think, oh, so when you do assignments with primitive types, they're different. And let me demonstrate. A friend. There. Okay. So if I say int a equals 6, and then int b equals a, okay, and then I'm going to say s out a, s out b. I'll see the question first. All right, cool. Would you recommend your C++ slides for just concept logic, or is that just kind of there on one? You can if you'd like. You might not gain a lot out of it. If you are, however, an engineering student and you want to continue taking programming courses, it might not be a bad idea to look a little bit about the C++ stuff because you will be transitioning to that. All right, so how do you do S out? You type S out and then hit tab. All right, so okay, I'm gonna hit run. This code right here is not helpful. I'll just get rid of it. Look at this code. I'm going to hit run, come up with what the answer should be. At this stage, you should absolutely know what you expect to see. We see 6 and 6. Why? Well, A is 6, B is A. We copy over the contents of A, which is 6, put it into B. So B is now 6. Print out A, it's 6. Print out B, it's 6. Great. So now I'm going to say A equals 7. Okay. I'm going to hit run. Think about what the output's going to be. You should have the right answer. So 6, 6, and then 7, 6, right? There you go. Why? Because, well, okay, 8, 6, copy over the 6 to the B, so we print out 6, 6. A is now 7, okay. Print out the A, well, it's 7. Print out the B, well, B was left alone, so B is still 6. Great. Now we're going to do friend a friend equals new friend. What was it? Bob Smith B at gmail.com, and they were born in 1999. And then we'll have great. Oh, that should be B friend. Okay, so S out A friend, B friend. Okay, great. So I'm going to hit run. The number stuff should be the same, but what do we see? We see Bob Smith and Jane Doe. Great. Now I'm going to say A friend, no, B friend equals A friend. And I'm going to print out the same thing. And nothing should be crazy. I'm going to hit run. What should we expect to see? Well, we see Bob Smith and Jane Doe. But then I said, okay, well, you know, a friend is not like B friend equals a friend. So we print out a friend. Well, a friend's the same. No, B friend should be the same as a friend. Bob Smith, Bob Smith. Cool. Now here's where people get confused. But if you are getting confused, it's because you're trying to connect dots that aren't there. The value in the variable is what gets copied. What is in this variable? What's in this variable? Is it the object? No, it's a reference to that object. So now, if I say, a friend, hey, let's set your birth year to 2001. And now no, that won't work because it didn't change. Let's set last name to bleh. Okay, so we are now saying, hey, set your last name to bleh. And I'm gonna hit run again. And now suddenly, we see Bob bleh and Bob bleh. The naive issue here is if you're like, well, hold on, you modified a friend. You never touched B friend, but then when you printed out B friend, we saw the Bob bleh. What's going on? It's because you're connecting dots that aren't there. Say it with me. You copy the contents of the variable, not the object, the variable. So the contents of a friend, whoop, that's not right, is a friend is the address of Bob. B friend is the address of Jane. It's not Bob and Jane. It's the information we need to get to them. So we effectively did this. So if I say a friend, change your name to Bob bleh, well, B friend is a reference that gets me to that exact same one single object that we modified. To make things even more obvious, for lack of a better term, let's do B friend set to bleh. And we'll see that a friend was also modified because they are both references to the exact same single object after I did this. If you're struggling with this, that's typical, but it's because you're trying too hard to connect dots that aren't there. You copy over the contents of the variable. And what's the contents of the variable? Well, when you have objects, it's just the references. So when you copy a reference, it's two references to the same one single object. Questions about that? Because I know this can throw people off a bit. And don't worry, this is being recorded. It'll go on YouTube. All right, so I'll assume everything's okay. All right, contact list. Great. We now have a bunch of friend objects. But we want to have a contact list to keep track of our friends, okay? And what should this field have? Well, or what should this class have? Well, you know, a way to keep track of the friends and maybe a count of the number of friends we have. Okay, so I want to create a new class. Right-click source, new Java class, contact list. Great. If we go back here for reference, right, we name the class, and then we want to have our class fields, our attributes, our variables, whatever we want to call. Size, private int size. Well, this object will keep track of the number of friends we have. And then we'll also have a private friend array, friends. We'll use an array to store the friend objects, or more accurately, to store a series of references to friend objects. So these are the two things we're going to want for our contact list. Account, we'll use an array to keep track of the friends, because an array is just like a series, a sequence of things. So it's a great way to hold on to multiple of something. And account to keep track. We'll just use an int. if we did something like this in Python, this is how we would start it. We'd create our constructor. We'd say self friend count, self friends as an empty list or something, right? In Python, we've got a little different. Capacity, ooh, we don't even need the capacity. In fact, I should probably, I'll change that a little bit later, but whatever. Here's what we could use for our contact list class. And you'll see a couple of extra things here that I didn't include in my example. I'm actually going to not include the capacity because we don't actually need it here, but it could be there. Private int friend count, I called mine size, whatever, I'll call mine size. And then we have our friend array called friends. We also have this static final int default capacity. This is a constant that I'll actually throw in here, and you'll see we'll see where this gets used in a moment. But there. And now we'll want a constructor. So let's start with a constructor public contact list. And this will just do nothing. Whenever we create a new contact list, we'll probably want a, well, there'll be no friends in there yet, so size equals 0. Notice that this value 0 had nothing to do with the parameters here, right? It's just when I create this object, how many friends are in that contact list? None, so the size should be 0. Now the other thing we're gonna want is an array to hold on to my contacts, my friends. But the trouble is, at this point, what we have is we've declared a variable of a friend array variable called friends, but there's nothing actually there. So I'm gonna wanna make the actual array. So how do we do that? Well, if you forget, you can go back and look at the example code as we saw before. Friends equals a new friend array, but we have to specify how big we want that array to be. And now we are in a bit of a pickle because we know that once we create an array, it's got a fixed size. But I don't know how many friends I have at this point. So the trick is, and this was a suggestion someone made last class or maybe the one before, is you create an array that's a certain size that has empty room in it. And whenever you add something to it, okay, great, we have room in our array. We'll just add the information we need to the appropriate index. So what I'll do is I'll start with the default capacity. I heard a boop. 0, that's not a great idea. I don't even know if that's allowed. Let's see what happens. Oh, maybe it is. Default, we'll just start it with the default capacity, and this was set to a constant here. Now you might say, why do it this way? Why not just write the 10? And you're right, but one of the handy things that people often forget about with constants is if I go here and you show me this code and you only showed me this snippet, I'm gonna go like, wait, why 10? What's up with that? Like 10, is there a meaning for 10? Is there, like, what does 10 mean? Where if you show me this, you're gonna go, oh, just some arbitrary default capacity, okay. And I'll know that exists so I can, oh, okay, it's 10. So another thing of the value of the constants isn't just that, well, this ensures the variable's not changed. It's also great for adding descriptiveness to things. So there, we have a constructor. A cool thing about Java is we can actually have multiple constructors. So the default capacity is 10, but let's say you're making a contact list for someone you know that has like a bunch of friends, a lot of friends. Well, maybe what I can do is specify to the constructor like how big the capacity of the array should be to start. Just make sure I give myself a lot of overhead, just in case I have a lot of friends. Is this necessary? No, but can I do it? Yes, great. So at this stage, I have two different constructors. Note, they have different definitions. Now, they don't. If you hover over here, it's going to say it's already defined. We have a problem. You can't do this. You have two constructors with the same name. Well, Now I have two constructors with the same name, but they have a different parameter list. So I'm going to quiz you. You've likely never seen this before. Let's say I'm going to make a contact list now equals new contact list versus my other list, contact list 200. Which constructor do you think this line is calling, and which constructor do you think this line is calling? It's going to go and call the constructor that matches the parameters. So here it's like, okay, they're calling a constructor and there's no parameters. So it goes and it looks for a constructor with no parameters. Here it says, oh, they're calling a constructor that takes a single integer. So they'll go, okay, well, it's not this one. Oh, here's one that takes a single integer. If I did something like this, oops, 700, it's going to now say, well, there's no such thing as a constructor that takes two integers, because that's correct. I didn't write that. So we have multiple constructors, and depending on which the parameters are, will depend on which one gets called, which is pretty cool. Any questions about any of that? But otherwise, you'll notice they're the same. It's just the one, oh, okay, I could specify the starting capacity. Great. So this is called overloading. When you have multiple methods, in this case constructors, with the same name, but they just take different parameters. What did 200 represent? That means it's going to make an array for friend objects that has 200 spots available, 200 empty seats. Where the one where I didn't specify the 200, it just goes and creates it with whatever the default capacity is, which I happen to set up to here to be 10. Yeah, that's all. Cool. All right, I guess we'll end there. For those of you that have lab on Thursday, you will be asked to do some things that are discussed like just below here, but I'm confident you'll be capable of reading the rest of this here. But we will pick up here in lecture on Friday. Otherwise, any last questions before we wrap up? Did you have to put the word capacity before the? No, I didn't actually write that. You mean like how here I said it says that's actually IntelliJ. Like I didn't put that. If you watch, I say 200, and then IntelliJ goes, oh, that was the capacity from this constructor. That's the variable capacity. So it was just being helpful. But no, I didn't actually write that. Good question though. Yeah, IntelliJ is just being nice. Friends, were the square brackets there for, wait. Oh, okay, do we have class? Yeah, we do have class Friday, wouldn't we? We do, right? What? Yeah, what? Oh, is it really? Oh. So that's news to me. All right, whatever. All right, I guess no classes Friday. All right. For an hour if you want. I'll have to actually get the Minecraft thing working. Okay, someone asked a question though. Okay, friend capacity. Were the square brackets there or round? Here they're round because it's like calling a method. The square brackets are used when like with the array stuff. So we'll call these are parentheses. These are brackets. And these have a special name too. I just can't remember. I just call them squiggles. What are squiggle brackets called? Braces, curly braces or squiggly braces. Yeah, braces is the word that's common. But I stick with squiggles because I just prefer squiggles. All right, I'll see you all later. I have to get the Minecraft server started, I know. It's easier said than done these days, but I'll get on that. Gotta go. Yeah, all right, I'm heading out too. I'll see you all. I'll see half of you on Thursday, and I'll see none of you on Friday, I guess.